Okay, welcome then, and these are the solutions to the second part of the calculated preparation questions that were set. Okay, so first of all then we're going to start off with some of the higher order factorising, and in this question we can see that we already have some brackets and two separate terms, and as we should know, factorise means to put into brackets, and we need to look for a common factor first of all, so something that is common to x plus 3 squared and 4 multiplied by x plus 3. So another way of thinking of x plus 3 squared is if you square something, you multiply it by itself. So here we can see that it's x plus 3 multiplied by another x plus 3. And so here we've also got an x plus 3 in a bracket. So the common factor in this case is x plus 3. So we can take that out as our common factor for both terms. So imagine I've taken that one out. I've still got this x plus 3. So that needs to go inside this bracket. And this x plus 3 has been taken out here as well. So it's the plus 4 that needs to be carried inside the bracket as well. Now, if we have a look inside this bracket here, we've got x plus 3 plus 4. Now we can simplify that. So adding the 3 and the 4 together gives me 7. So fully factorized, this expression is x plus 3 multiplied by x plus 7. Now there is a separate way you could think about doing this question, and that is to expand and simplify both brackets. Okay, so this is an alternative way. It takes a bit longer, but obviously if you struggle to understand the first method there, this might be an alternative for you. So you need to use your FOIL method to expand these two brackets. So x squared plus 3x plus 3x, and 3 times 3 is 9. So that's expanding the double bracket. And this bracket on the right here, multiply through by 4. So I get 4x plus 12. Just get rid of that a moment there. So here then, 4 times x is 4x, 4 times 3 is 12. So now I've got all these terms, and now I can simplify them all together. So I've got this x squared term, I've got 3x plus this 3x making 6x, plus this 4x making 10x. And then I've got the integer number parts, so I've got plus 9 and plus 12, put them together makes plus 21. And now I can factorize this expression here. So I know I'm going to need two brackets because there are no common factors, x at the front of both. Now to make 21, it's either 1 times 21 or 3 times 7. The signs in the bracket are the same because of the plus 21. And I know they're going to be both pluses because they make plus 10x. So can I make 10 from 1 and 21 or 3 and 7? Then the answer is yes to the 3 and 7. It's 3 plus 7 makes the 10. So in here it needs to be plus 3 and plus 7. And as you can see, it gives me the same answer as the first version here. All right, but you might find that this method works better for you. Okay, on this one here then, I've got two terms, and the letter different, so there's no common factors there. 12 and 75 are the bit I've got to focus on, and what will go into both of those is 3. So I can take 3 out as a common factor here. It means in the brackets I've got 4x squared minus 25y squared. And now I need to look a little bit more closely at what's inside the bracket here. 4x squared, 4 is a square number, x is squared as well. 25 is a square number, and y is squared as well. And because it's minus, it's the difference between two squares. So I can factorize that into two brackets. 2x multiplied by 2x makes 4x squared. 5y multiplied by 5y makes the 25y squared. And as I said, it's the difference between the squares. So I need a plus in one bracket and a minus in another. And that then fully factorizes that expression. Okay, when we rearrange the subject of a formula, we want x to be on its own. In this type of rearranging problem here, I can see that x appears here with 3x, and on the right hand side of the equation I've got here as ax. So I want to try on this particular question to get all the terms that contain x on the left hand side of the equation. and all the terms that do not contain x on the right-hand side of the equation. So first of all, then I'm going to deal with this ax here, and to undo this I need to take ax away. So I'm going to take ax away from the left-hand side, so I've got 3x take away ax, and on the right-hand side I've got this 3w. Now this term here doesn't contain an x, so to remove that from the left-hand side I need to take 2y away. So I need to take 2y away from the right-hand side as well. So as you can see now, I've got all the x terms from the question on the left-hand side and all the other terms on the right-hand side. Now on the left-hand side here now, I can see that both terms contain an x. So now I can factorize the left-hand side of the equation. So taking x outside as a common factor, in the brackets I'll have this 3, take away this a. So let's factorize the left-hand side. Okay. The right-hand side remains the same because we can't simplify that. And now to get x on its own, we just need to divide both sides by 3 minus a. So I've already got 3w take away 2y on the right-hand side, and I'm going to divide it by 3 minus a. And as you can see now, I've got x on its own. So this now is the x is the subject, and this is the rearranged formula. Okay, a different type of problem we could have with rearranging formula is that one of the sides could contain a fraction or even both, but in this case just one. And the first real thing that we need to do is try and remove the fractions. Okay, so in other words, the denominator part of this fraction here, the 6 minus x, we can multiply it through and we can multiply the 4e by it. Okay, so on the left-hand side, it would leave me with 9x plus 2. And on the right-hand side, it would be this 4e that's here already, multiplied by 6 minus x. Now, I need to expand this bracket through. So the left-hand side at the moment is going to remain as 9x plus 2. And the right-hand side is going to be 4e times 6. So that's going to give me 24e. And 4e times x, which is going to be minus 4ex. And now we've got to the situation like the previous question, where we've got terms on both sides. We can see that x appears on the left as 9x and on the right as minus 4ex. And again, the strategy is the same as the previous question. Get all the x's to the left-hand side, all of the terms to the right. So this term here, minus 4ex, needs to come over to this left-hand side. So I need to add 4ex to both sides to do that. And this minus 2 here, it needs to go to the right-hand side. So I need to take 2 away in order to make that happen. So I've got the 24e already on the right-hand side. I know it's minus 2. And again, now we can see now we've got the x terms on the left-hand side. So I can take out x as a common factor again. So in the brackets, we'll go 9 plus 4e. And on the right-hand side, I've still got this 24e minus 2. I can't simplify that. And now to get x on its own, I need to divide through by this 9 plus 4e. So the left-hand side would be 24e minus 2, all divided by 9 plus 4e. And again, now x is on its own, so it's the subject of the formula as required. Okay, arcs and sectors of a circle there. Okay, we know for a full circle that the circumference is pi times diameter, and the area is pi r squared. So if I take out just a section of it, it's just going to be a fraction of these calculations here if we require them. So what I've got here in this diagram then is a flower bed, and the border is marked out. So we can see that the two lengths here, the two straight edges of the border are 8.6 meters. But I'm being told here that the complete border is 28 meters long. It means that I can now find the distance from A to B using that information, and that would be the arc length. Okay, so that's the arc length here, which is just a fraction of a whole circumference. So to find this arc length AB, then I know the whole board is 28 meters, and if I take away 8.6 and another 8.6, it will leave me with what's left for AB. Okay, so in this case here, taking that away there will leave me with AB being 10.8 meters. So I can now add that to my diagram, 10.8 meters. And now I can calculate the size of AOB, which is this angle here, which I am going to call theta. Okay, so that's what the question is asking me to do for part A. Okay, so I know that it's going to be the angle divided by 360 degrees. That's what fraction of the full circle this sector is. And I'm going to multiply it. Because I know the arc length, I'm going to use the circumference formula. So pi times diameter. So it's going to be a fraction of the whole circumference of the whole circle. So the diameter, well, this 8.6 here is the radius of the circle because it only goes from the center to the outside. So remembering the diameter goes all the way through the circle. So I need to times this by 2, which would make 17.2. Now then, I can put that into here. So there's the formula for the full circumference, and there's the fraction of it we need. That will give me an answer of 10.8. And now it's just a case of rearranging this. So as this, we're divided by 360 here, then I can do 10.8 multiplied by 360 by multiplying through. And I can divide this all by pi times 17.2. Now you're going to need your calculators to type that in. Okay, so do that. All right. And you will find that in this case, to 2 decimal places, you get an answer of 71.95 degrees. If you rounded it to 72 as a whole number, it's very close to it. That too would be acceptable. Okay, so we've got that now, 71.95. So in here now, I put that 71.95 degrees. Just remembering that the arc length was 10.8 meters. Now to find the area of the flower bed, again, this is just a fraction of a whole circle. So now to find the area, we can now use the angle to work out what fraction of 360 degrees we've got for the sector. And we multiply that by pi r squared. So remembering back that the radius is this 8.6 meters. So times 8.6 squared. So again, it's just a little bit of calculator work here now. So type that in again on your calculator. Okay. And round it to 2 decimal places. So hopefully you come up with 46.44 rounded correctly to 2 decimal places, and that's meters squared for the area units. And just specify here that I've rounded that to 2 decimal places. Section 13 then is about using the quadratic formula to solve a quadratic equation. Sometimes we need to do a bit of work before we can actually get to the stage where we use this quadratic formula here. Okay, so this is what I've taken off the formula page of an exam paper. So we can see that we're going to get a term with x squared, a term with x, and a term with c. But the most important thing is the equation must be equal to 0 before we can use this formula here, minus b plus or minus square root b squared minus 4ac all over 2a. So here I'm going to need to rearrange this formula, this equation here. So I'm going to have to expand this bracket out and this one, and then rearrange it so that the right hand side of the equation is equal to 0. We've been told in the question to use the quadratic formula, so there's a big clue in itself. The other thing we're looking for, that if it doesn't mention that, is giving our answers correct at 2 decimal places. It's quite a giveaway on a calculator paper. So first of all then, I'm going to expand out x minus 2 squared. So remember, that's x minus 2 multiplied by x minus 2 on the left hand side. On the right hand side, I'm going to expand this bracket. And don't forget, it comes with this plus 1 here as well, so don't forget that. So using FOIL on this side here, then we get x squared minus 2x plus 4. And on the right hand side, I expand the bracket by multiplying both terms by 2x, so it gives me 4x minus 2x squared plus 1. Remember, now I want this side here to be equal to 0, so I want to remove everything from this side. So to do that, I'm going to come to this term here first. Let me change the color of the pen. So I'm going to come to this minus 2x squared. And to remove that, I need to add 2x squared. So I'm going to need to add 2x squared onto this x squared here as well. So that's going to give me 3x squared. I'm going to come to this 4x, and I'm going to take away 4x. Means that I'm going to take away 4x from minus 2x and minus 2x. So minus 2x and minus 2x over here simplify gives me minus 4x minus another 4x. So in total that gives me minus 8x. I'm going to have to take this 1 away from here. So it means I'm going to have to take 1 away from the 4. So that leaves me with plus 3, and r equals 0. So I've now got to the stage now where I've expanded everything and I've rearranged it so that the right hand side is equal to 0. See now that a is equal to 3, b is equal to negative 8, and c is equal to this positive 3 here. And now I can bring in this formula here and I can substitute in. Now, anywhere that I substitute any of these values in, I use brackets. Okay, so that's something I always do, whether it's positive or negative. So you're going to need to set it up correctly on your calculator. So we start off with this minus b. So the minus is already in front of the b. And now I've got to put the b in. So that would be minus 8 in the bracket. Now you can't type both sides in, plus or minus, into the calculator at the same time. So we want to do this 2 separate ways. So I'm going to use the positive version first. Minus the root. Now it's b squared. So that's minus 8 squared. Take away 4ac. Notice how it's all together. So type it in all together, but use brackets. So the 4, a is 3, so put it in a bracket, and c is also 3, so put it in a bracket. And then on the denominator, we've got 2a, so that's 2 times 3. So again, I've used the bracket everywhere that I need the letters replacing in the formula. Okay, so type that in on your calculator as you see it, and you should, to 2 decimal places, get 2.22. And that's correct, to 2 decimal places, so x is equal to 2.22. Or, now we've got to come up with our second solution. Okay, so the clue is give your answers, so that suggests more than 1, so don't forget to go back and use the minus from the plus minus in here. So, again, it's the same information going in to the calculator in here, so 4 times 3 times 3. And that's all over 2 times 3. So all you need to do with your calculator is arrow back in and change this positive for a negative, and it saves you typing it all in a second time. On this one here, you should get a solution of 0.45. Again, that's given correct to 2 decimal places. My question 14 then is all about similar shapes, and the area in this case, sometimes it's to do with volume. So we've got these 2 vases that are similar, mathematically similar in size, so that means one is an exact enlargement of the other. Okay, so a decorative glaze covers the surface of each vase, and the glaze covers an area of 400 centimeters squared on this smaller vase here, and 576 centimeters squared on this larger vase here. So when we're dealing with this, we need a scale factor, and because we're dealing with the area, it'll be the scale factor that's squared in order to multiply to get from 400 to 576. Okay, so we need to find that scale factor before we can even consider finding the height of this smaller vase here. We know the height of the bigger vase is 48. So in this case then, the scale factor squared, so we multiply by this scale factor here squared, is equal to this area divided by this area. So 576 divided by 400. Okay, so the scale factor squared is going to be equal to 1.44. So that's the area scale factor. So we multiply 400 by 1.44 to get to 576. But I want to know what the linear scale factor is that will map my height onto this height. So to find the linear scale factor, we need square root 1.44. So square root in that gives me 1.2. So to multiply and divide lengths, we would multiply given length or divide them by 1.2. So now we're being asked to find the height of this smaller vase here. So we know the height of the larger vase is 48. So to find the height on the smaller bars, and we take the height of the larger bars, which is 48. And now, because we're going in the opposite direction, we need to divide it by the linear scale factor, which is divided by 1.2. So pop it now on the calculator, tell me that the height of the smaller bars is equal to 40 centimeters. Okay, the next two sections then are about these formulas here for non-right angle triangles. Although it does say any triangle, you can use them in a right angle triangle. But if we've got a right angle triangle, don't forget we would use our SOHCAHTOA to solve those sort of problems, but you can use these. Now, we've got these three rules here. We've got the sine rule, the cosine rule, and the rule to find the area of any triangle. So as you can see here, we've got three corners, A, B, and C, so three vertices, and labeling the triangle. Lowercase a is opposite angle A, lowercase b is used for side B, which is opposite angle B, and the same goes for C. Okay, now we're being asked to calculate this length AB here. So we've got two sides and an included angle, and when we've got two sides and an included angle, we would use the cosine rule to do it. Now, if I'm labeling these sides here, then I know that this angle here, A, opposite that would give me side A, so that's lowercase a. Here is angle B, and opposite that is 10.8, so we're going to call that lowercase b. And the angle that we need to use in this question is angle labeled C, so it's lowercase c for this side, and that's the side that we want to find in this question. Okay, so we want to find this side here, so labeling up my three sides again. So this is to find a squared. Well, we already know what a is, so we just rearrange this formula. So we want to find c, so that would be c squared. So we would just rearrange this so that we use the other two sides instead in this formula. And again, we wouldn't want to use c in here, so it would be minus 2ab. And because we've been given angle c as 96, it'll be the cos of c. So it's just a rearrangement of the cosine rule. Okay, so in this case now then I can now start substituting my values into this equation. So c squared is equal to a squared. So that'd be 7.4 squared from the diagram, plus b squared, which is 10.8 squared from the diagram, minus, now all of this is all together, so type it in using brackets on your calculator. It means to multiply it all together, so that's 2 times a times b, 10.8, times the cos of c. So that would be times cos of 96. Now, if you type it in exactly as you see it here on your calculator, okay, it will give you an answer of 188.0107, and there was a few more values on the display. Now we don't want c squared, we want c, so we must remember now to square root that. So you want to put all that in on your calculator so that you don't lose some of your rounding effect. So on your calculator, just press your square root button and the answer function, which is at the bottom of your calculator, and that will put all the 188.107 and all of the rest of it into here so that you don't lose any of your accuracy. And square rooting that gives me an answer of 13.715. And again, there were more digits on the calculator. So considering my rounding now, if I have a look at these other two sides, they're rounded to one decimal place. So I'm going to round this one to one decimal place as well. So I need to use the one rounding. So the 13.7 will stay the same. So therefore, the length of AB is 13.7 meters. And I'm just going to stress that I've rounded that correct to one decimal place. And finally then, using the same triangle, I'm being asked to calculate the area of this triangle. So again, we've got there's C, there's A, there's B. So to work out the area of this triangle, it's half AB sine C. So we know angle C is 96. We know A is 7.4 and we know B is 10.8. So again, I can just substitute the key values now into my calculator. So A is 7.4, B is 10.8. And we multiply that by sine C, so that's sine of 96. So again, because it's all together, it all means times in through. So type it as you could see it there, or put times in between each of the terms here on your calculator. Okay, it's not necessary though. Okay, and again, type that in as you see it on your calculator. Gives me an answer of 39.74 when I rounded this time. And that's meters squared is the unit, and I rounded it correct to 2 decimal places. Okay, so using the formula there for area of a triangle. I hope this video has been helpful for you. Okay, and good luck now with your assignments.